Hello everyone. In this video, I want to walk you through the steps of setting up and configuring an RedHat OpenShift cluster for serving large language models as showed in this blog post over here on AI on OpenShift.io. And we will use the information from here to deploy a large language model, namely the Mistral 7B Instruct v02. And I will walk you through the prerequisites for setting all this up and deploying the model and testing it. First thing that we need is an OpenShift cluster. Now you can have a cluster deployed anywhere like on-prem or in the cloud. I have one created here on AWS. It is a vanilla cluster, and I will first log in now with the credentials I have to start the configuration of this cluster. So the first thing, because initially it's only the kubeadmin user that is being created, so I will use that information to log in. As you can see, the cluster is just installed. Need to make a little bit of cleanup over here from the original deployment. So for the overview, we have a version 4.13, and the cluster has one control plane and 3 workers. We will also add a GPU node because it is required to serve the model. We will walk you through on how to add a GPU node machine set, and then install the required operators and install all the required operators as described here in chapter 6 of the RedHat OpenShift AI for all the prerequisites that we need to have for serving large language models. So the first thing that we need to do with our cluster is to create some authentication. So I'll go home here, see there is the cluster configuration that I need to update. So we will add an identity provider. Let's use HD password. We need to provide a file over here. So you can do that by browsing and getting the file that you have created on your local machine and upload it here. To create such a file, you would need to initiate some commands using HD password, something like this. So you create HD password -c it's create, and then -b it's to add the user and to add it over there. So if you run this command, then you will see that we have this password over here created and has one user inside, and then to add additional users you just add. So the first one is the user, the next one is the password. Similarly, you can add for the cluster admin the same thing over here. So now we don't need to add the min IC because we already have the file created, so we don't need to override that. In any case, now we have the identities added here, a few users and the cluster admin. Now that it is added, we also need to configure one of the users to be an administrator. And as you have seen, I had in the file a cluster admin user, and in order to elevate that to become a cluster administrator, we need to do the following. First is that we need to log in into the cluster with the kubeadmin user, and the cluster URL is here. So we need to provide the kubeadmin password that you get after you install your cluster. And now we need to add a new group where we will to which we'll attach the policy of the administrator. Okay, and now we need to add a policy. So first we created a group, then we added the cluster admin user to this group, and now we add the policy to make the my local admins group as a cluster administrator. So any user that is part of this my local admins group will become an administrator. Okay, so now we can actually log in with our new user. Okay, so the password that you supplied earlier to pass in now. So now we are cluster administrator. Now that we see that is working, we can also do the same thing in the console. So now you see that we have both kubeadmin, this is the original user, and then the password one created. So we have cluster admin, fill in the password. And now we need to start installing the various operators for supporting the installation. The operators are found in the operator hub, and the first one that we need to install is Tecton, because it is required by RedHat OpenShift AI. So we will install this, leave the defaults on, click install. This will take a second. I will pause the video here and resume when we're ready to continue. Now we see this operator has successfully installed. We don't need to do any configurations with it for now. Now we will need to have object storage, S3 compatible one, in order to store the model data. And you can reference this from the outside if you want to. So this will be used by RedHat OpenShift AI. But if you want to keep everything inside the cluster, then you can do it by installing the data foundations operator. Select data foundations, leave everything with the defaults, and click install. This will take a while, so I'll pause the video here and resume when we're ready to continue. Now the operator has been installed, but before we can actually create the storage system. If you are like me, like the number of nodes that we have, like I said, we have one control plane and a number of workers, so we are not single node installation, and we're not in HA mode installation for the control plane because it's only one. Because of that, we need to do a little hack before we can actually configure our uh, data foundations operator. So where we'll go is for the projects. I'm going to look for OpenShift console, and in here at the pods we see that there are two which are pending, right? So because of that, the UI here didn't properly reload, so we need to kill all the console pods and let them respawn. We'll relog in into the cluster, and then we can continue with the configuration of this. So we'll delete the first one, delete the second one, and now we'll delete the one that's actually running. So this will render the UI unusable, but give it a few seconds and it should be able to let you relog in. Alternatively, you can check with the CLI tool, so OC project OpenShift console. OC get pods to see the pods, and we see that we have the console pod running again, so we should be able to relog in the UI. Now, once you're back in the UI, we can see that under storage we have data foundation, and it shows that it's ready, so we can create a storage system, and we'll create on one. Since we only need bucket storage, we will select the multi-cloud object gateway, leave the defaults on, just click create, next, create storage system. This will take a while. I'm going to pause the video here and resume when we're ready to continue. Everything should be ready when you see all the pods in running state over here, and also that you have on the UI side under storage you have object packet and object packet claims. Now, before we continue, let's have a look at the software resources. So we can see that we have up to 64 CPU available and 245, almost 246 46 gigabyte of RAMs available. But when we go to the compute and we look at the nodes, we see that there are quite a few pods deployed everywhere and 16 core. So what we could do is basically increase the number of machines over here so that we have more machines available, so things will go faster with the remaining operators that we need to deploy. So I'm going to machine sets and increase it from 3 to 4. So what this will do is that it will add another machine set. We will use later on these machine sets to add a special one for the GPU following this blog post over here. I'm going to pause the video here now and then continue when resume it when you're ready to continue. So now we have increased our worker pool to 4 machines, and we can verify that the machines are all in provisioned, and then we also have the nodes attached and working. So now we can go back and start adding the other operators. What I will follow is this deployment option. So I will install RedHat OpenShift AI. To do that, in the documentation for installation of RedHat OpenShift AI, there is a special chapter for serving large language models, and that tells us that we need to have a few operators installed over here, and that there's a way to do it like an automated installation and manual installation. So if we want to do it in an automated fashion, then we follow this part over here, and we see that we need to have installed RedHat OpenShift Service Mesh Operator and dependent operators. And I believe that is this one. Yes, OpenShift Service Mesh. So it tells us that we need to install these operators from here, right? So the first one that we need to install is OpenShift Elasticsearch. We're gonna go back to our cluster, and we have OpenShift Elasticsearch. We're gonna install this, click install, and wait for it to complete. Now the operator has been installed. The next one we need is the RedHat OpenShift Distributed Tracing platform. So we are going back to the operator hub, distributed tracing platform. Install this, leave the defaults on, click install. Now that the tracing operator is installed, we can go to the next one, which is the Kiali operator. So going back to the operator hub, type in Kiali, and we need the one that's provided by Red Hat. Click install, leave the defaults on, click install. Now this operator has been installed. The next one we need is the service mesh. Now the operator has been installed. One important note that we have here, so the installation says that we can start the configuration, but one important note we have the installation of notes for RedHat OpenShift AI is that to enable automated installation of Kserve, we need to only install the required operator and do not perform any additional configuration on the service mesh control plane resource. Uh, then we need to continue on with the serverless operator. So to install the serverless operator, we are going to go to the operator hub, type in serverless, sorry, not this one, RedHat OpenShift serverless. Leave the defaults on, click install. So the serverless operator has been installed, and now similar to the previous note is that we only need to install the operator and do not perform any configuration. Next, we could continue with the data science cluster operator installation and creation. However, since we need to have GPU for the LLM model, we need to perform that setup first. Remember that our cluster, if you go to compute the nodes, we only have this type of nodes available that do not have a GPU resource. So now, in order to add another node that has a GPU resource, there is this blog post created over here. It is a little bit old. It's for RedHat OpenShift 4.2, but it is still good enough to continue and perform the installation as such. And we will do this next. For adding the GPU node, in essence, what we need to do is to get a copy of the machine set that is defined already in the cluster and change the type of machine that's being deployed with it. So what we need to do is get the machine set to know first what machine set we have available in the namespace OpenShift machine set API. So here is our machine set. Then we can basically get this now. What we want to do is to copy this one over into a GPU node. So we'll change this to GPU. Sorry about this file over here, I don't know what it is. Anyway, so now that we got the machine set and changed its name from worker to GPU, what we want to do is to edit this file and change the name here from worker to GPU. Okay, the cluster needs to stay the same, we just change its reference. And now what we want to change is the type of the that this stays the same. So what we want to change is the instance type. So to get an instance types, we need to get something from accelerated computing, but we need something that has 24 gigabytes of VRAM, and we can find something here. We need one GPU with 24 GB of VLAN. vCPUs we could use less, so let's use this one. So we're going back to our file and changing this configuration here. Okay, region stays the same. We need one. And so in the beginning we need one replica. Okay, so we're gonna have a new machine set created of type worker that is going to use the same credentials as before, but the instance type is going to be G5 4x large. Therefore, the machine set reference instance is going to be changed from worker to GPU. Save this file, and now that we have this file, we are going to use OC create -f, the GPU one. Now, what this means now is that inside our OpenShift, refresh this, go to compute, go to machine sets, we have the other machine sets added over here, and since this is need to be to one machine, it will ask provisioning. So it will take a while, and then I resume once this is. So the node is now provisioned. However, it turns out that I had a limitation on my account that I with the credentials and the setup that I have, so I had to change the machine type instead of G5 4x large to just G5 x large. So the machine set was already defined. Easy way to change that was to just come into the YAML definition here and scroll down to the type of the machine and the specs. And here, instead of G5 4x large, just change it to G5x large, save, and then delete the node that was failing, because I had here a node that failed to provision. Right, so sorry, at the machines I had a node that was failing to provision, so now this was basically the node that was the G5x large. So once you delete this one from here that failed to provision, the automatic provisioning will kickstart again and provision this time the new type of the node. So now we have this node installed. The next thing we need to do is to install the Nvidia operator. To do that, we first need to install the Nvidia node feature discovery operator. So we're going to come back to the operator hub and type in NFD. And we're going to use the node feature discovery from RedHat. Install that, leave everything as it is, click install. I'm going to pause the video here and resume when we're ready to continue. The node feature discovery operator has been installed. Now, according as per the installations, we need to create an instance of it. So we are going to go in here, view the operator, and then create a node feature discovery inside the OpenShift NFD. I'm going to create an instance, leave the defaults on, and just click create. I'm going to wait for this to complete and resume the recording once we are ready to go on. Before we continue with the Nvidia operator installation, we need to verify that the feature discovery has been successfully completed. So we're going to run two commands. Okay, and we can see here that we have this node that has 10DE present as requested. So we have this device, and then we can also go into the node label details, go to the compute again, nodes, this is our node, and we go to details, and if we look in here for the labels, we should see somewhere PCI-10E present equals 2. There it is. So we have confirmed 2 different ways the installation has been successful. So now we can proceed to the Nvidia GPU operator installation. So for that one, we are going to come back here, go to the operator hub, type in Nvidia GPU operator, click install. This is going to take a little bit, so I'm going to pause the video and come back after it's done. As per the documentation, it says that we should expect this operator to take about 20 minutes to install. It's written somewhere in here. In any case, we're going to wait some time until this is done and then come back and create a cluster. So the operator has been installed. Now we need to create a cluster policy, and actually it takes the cluster policy between 20 and 30 minutes to create. So we're gonna go in for the operator, create a cluster policy, the default's on, and just click create. Now we can verify the installation by running this command, and we can see that everything is up and as it should be. So next we can go on and install the RedHat OpenShift AI operator. Now the operator has installed, and we can have a look at it to see what exactly is happening here. So we have the default DSCI, and if we look here at the default DSCI object, we need to see that the Istio system value is set to managed. So if we look at the YAML, and we have the Istio system is set to managed. Okay, and next we need to install into the default DSC project. When we create this in the YAML tab, we need to see that knative serving is set to managed. So when we're creating the cluster, okay, so install operators, RedHat OpenShift AI, create an instance, and if we look at the YAML definition, we need to see that kserve is set to managed. Right, so we need management state managed, and then serving knative serving management state managed. Self-type the managed, ingress gateway, manage main state managed for kserve. So now that we have this, we can click save and in essence create the cluster. This will take a while. I'll pause here and resume when we're ready to continue. So for verification, we need to see if the Istio system has been created for service mesh. So we're gonna look into the pods, available pods in the workloads area for the Istio system. The next thing, we need to see that knative serving is created for the serverless. Bunch of pods over there as well. And then we need to look into ODS applications and see that we have the kserve control manager available. ODS applications, and here it is, kserve control manager on. So this means that the installation of RedHat OpenShift AI was successful, and therefore we can now go to its console, which happens to be under the same namespace here, RedHat ODS application. Click to routes, and then we log in with OpenShift, and we are going to use the cluster admin user we used before. And the password is the one that you encoded when you created the HT password file. And now if we go under model serving, under cluster settings, we see that single model serving platform is available. And then this means that now we can create a data science project. I shall call test LLM. And in here we can deploy single model serving platform. Before we can actually do that deployment, we will need to create a data connection where we store where the model files are stored. But this data connection is referenced from the outside. So whenever you created this test LLM project in the data science space here, there is another namespace that has been created inside OpenShift, which is called test LLM. So we are going to go to storage and create an object bucket claim. And we can call this LLM bucket. Select the storage class and then click create. Now we will need this information from here in order to set up the data connection for it. And this means that inside the RedHat OpenShift AI console, we go to data connections, add data connection, and we call this LLM bucket. The access key, it is basically the one that has been created here. This is the access key. I'll copy over all the information. Secret key. Now, don't share this with anyone. Of course, I will delete this cluster after this demo is completed so that you cannot access it. Bucket name. Okay, now the endpoint. The endpoint is written here like this, but I don't want to use HTTPS. because it's not necessary, because I'm going to work with it internally inside the cluster. So therefore I'm going to go to OpenShift storage, and here under services we have the S3. So we're going to copy this, and we have the node port 80. So we're going to put the endpoint, and we add the data connection. Now this has been created, and the next we need to actually upload the model files before we can deploy the model. But before we deploy the model, we will need to select the runtime. So we see that we have several ones available here. However, in our little demo, there are two different serving runtimes. So the standalone inference server or this one. So in order to deploy this one, VLM, right, we're going to go to the console and add serving runtimes, and then add this YAML file. So our console is here. No, this one. And serving runtimes, add the serving runtime. It's a single model one. It's a REST, and start from scratch. And we will need to use the YAML file information, VLM YAML. So we have the YAML file over here. Copy the information, go back to our console, paste it, and we click create. So this instance has been now created. So now when we go back to our data science project, when we want to deploy the model, we also have this version available. But first, as I said earlier, we need to first upload our model to this bucket that we created in the TestLM project. Before you upload the model, first you need to grab it. So if you Google Mr. AI D7B instruct V02 model as instructed in here, okay, so here is we need to deploy this one. So you can Google it, go to Hugging Face, and then you need to get a file from here. This one you obtain from cloning this repository, and you need to do the git LFS install. So you need to install your LFS package for Git first on your, depending on your operating system, and then you can do this git clone. You need the full model, so you need to use this command. Don't just get this with just the pointers. And then you will have the model in here. Right, so if we look at the size of it, it's 55 gigabytes. So next step is to upload this model onto the S3 bucket. To upload files to an S3 bucket, regardless of the fact that it's on the data foundation operator or directly on S3, we can use the AWS CLI tool, and in order to access the right bucket, you need to create a profile configuration for that. So under your home folder, there should be a .aws folder that has two files in it, config and credentials, and there you can specify profiles for the buckets that you need to access, the region, and what type of output you want whenever you query those. This is all found in the AWS S3 documentation. So here's the config, should have the bucket that you're using, and then the access key and the secret access key configured in there. So now you can actually use the AWS command line for that in order to copy the information. So before we actually start copying here, we need to remember that we need to be one level above, because we need to copy the entire folder, the contents from here. And if you don't remember where you need to get the information from here for the bucket, it's in your project. If you go to your test LLM project under the OpenShift console, you can see the object bucket claims and reveal the values, and you have the access key and the secret key from here. To install the AWS CLI tool, you just search for it on Google, and you get for the installation instruction for different operating systems. I'm using Linux, therefore I'm gonna use this one. So I'm gonna curl with this in just use this folder. Okay, download completed. Unzip it. Then it actually created this AWS folder here, right? So I'm gonna use this command. It's asking for my password, obviously. So if we do now AWS version, I can see that it is installed. Right, I didn't run the whole command here because the user local bin is already in my path. Now we do have the AWS command CLI tool installed. We did create the profiles. Now we need the endpoint, because when we need to upload the files, we will actually need to get the external endpoint to access the bucket. So that is in the OpenShift storage under networking routes. This is the S3, so we'll need this location. And now going back here, we need to do the following. AWS, we use the S3 sync command. The profile is called LLM bucket, and then we need to endpoint. Just let's make sure. Yes, LLM bucket. Okay, so once again, AWS S3 sync profile. This is our endpoint, and then what we need to upload is this particular folder. We'll upload it as is to the bucket where we want to upload it, and the name of the bucket. And the name of the bucket is in the test.lm workspace. and remember that we need to add these contents into a folder. So we are going to use the same folder name. So the contents of this folder will be uploaded here. This will take a while, so I'm going to pause and resume when it's completed. So now that the upload has completed, we can check the contents of the bucket to see if it matches the one from the folder. So we need to list with -al to see that we also have the hidden folders, though I don't believe this should have been uploaded. In any case, the model files have now been uploaded, so we can proceed to the deployment. To go to the deployment, we will switch back to our RedHat OpenShift AI dashboard, and here we have the single serving platform. Notice the warning that the model serving type can be changed until the first model is deployed. After that, you need to recreate a new project in order to use different model type serving. So I'm going to deploy the single model serving, and I'm going to call LLM test. Or actually call it Mistral 7b instruct. Now, serving runtimes, we have a few to select from, including the one that we created, so let's select this one. We do have an accelerator to use, and model server size, 2 CPU, I think we only have 4 CPU on the model, so let's keep it small. Model location, so we have the RAM bucket, and then the path is this one. Put here, including the trailing slash. Forgot to select the framework, right? Okay. Alright, so let's click deploy. Alright, so my earlier attempt to deploy with the settings that I used did not work. And the reason for that is that it appears that when you are deploying large language models, you need to have or it's better to have the same amount of physical RAM as you have for the GPU RAM on your node. Otherwise, you will need to do some tuning of the model loading procedure. And since we are using the VLLM engine, this one allows us to do some of these things. And the method is called quantization. So basically, for example, we can specify the type of the model weights and activations, and we can reduce this to half. So we're going to use float 16 for this, so we reduce the size of those weights, and at the same time there is this additional parameter max model length that we can use to reduce it. So what we're going to do is that first you need obviously to delete the deployment that didn't work. And then in serving runtimes, you go to the LM here that we added, and then add a couple of parameters, the D type as I mentioned, and the max model length. Now, I don't know what exactly is the relationship between this number and the memory that's being used over there and the size of the model. However, this seems, so it's a trial approach to determine this number. This one seems to be working in my case. So if I look here, I have a G5 X large node that has 4 vCPUs and 16 gigabyte of RAM, one GPU with 24 gigabyte of VRAM. And I needed to use those values as I mentioned there for the deployment. Now, also when you create the deployment, you need to use the custom uh, deployment size, because if you use the small one, you can see here that it's using 5 gigabytes of memory already. So we go to metrics and we can see that it's using above 5 gigabytes of memory. So the small deployment, it's not enough, because that one, the maximum limit is 4 gigs. So you obviously need more. So I requested 8 to grow up to 14. And you can see that here in the deployment that I have. So I did custom, and I have 2 CPUs with 8 gig, 3 CPUs to 14 as the limit. I have one accelerator, the GPU. So then it will deploy this model, and you'll get this inference URL for it. There is a nice trick to this URL, is that if you put it in a browser and then you put /docs #/default, you get all this, so you get more information on how you can actually query the model. So I'm going to use the /view on /completions in the command line in order to query for that model. So here it is. I make a curl request to that URL /view on /completion, some additional some headers there, the type of application JSON, and then the content. You need to press the model type and then the prompt. San Francisco is A, and how many tokens you want as return, and the temperature. Click hit enter. So I got a response: city that is known for its beautiful weather, diverse population, and stunning views. So there you go. The model was able to provide a response. Now, another thing that I mentioned in my earlier video was that when you upload the content from your local folder to the bucket storage, you upload also the hidden folders. Well, that is the cache from Git, and actually you don't need that. So you just need these files from here. So you don't need to upload the gitignore and .git folders. And that because when you deploy the model, let me go back to that view. Yeah, when you deploy the model, so you look at the pods over here, the logs. So you have the storage initializer. It's basically the one that downloads the stuff. So you only need these files in order to be able to successfully load the model. And then you have the other, this is actually the container that has the model, and this is how you get to it. So that's why when you look here at the details of the pod, you see 3 out of 3, then they are ready. You also look to serving, and you see that everything is okay. You see the revisions, 4 out of 4 okay, the routes 4 out of 4 okay. Alright, so this concludes my demonstration for deploying an LLM model. Good luck in testing your own.